All right, welcome to Static Electricity Practice Probs, and here we go. So outer electrons in metals are not tightly bound to their nuclei. They are free to roam in the material. Such materials are good conductors. Electrons in other materials are tightly bound. They're not so free to roam. These materials are then good insulators. All right, number 2, when you scuff your feet across a carpeted floor in your socks, why do you get shocked when you touch a light switch or doorknob? Explain using at least 2 concepts of static electricity. So this takes us back to the John Travoltage FET demo. You know, if you're just like him and you're standing on the carpeted floor and you kind of scuff your feet along the floor, you're going to become charged by friction and have some excess electrons all over you like that, right? So you're going to become charged by friction. So there's our first concept, charging by friction. So you're going to pick up some negative charges off the floor onto you. And then you go over here to the door per se, and there's a metal doorknob right there. And you go and touch the doorknob. I know your arm's not that long. Then you're going to give these electrons a path to ground to go into the doorknob and into the door. Oh, so that means you will then actually have a neutral charge, and we would say you grounded yourself. Okay, grounding, taking those charges off of you and to the door and to the ground so that you become neutrally charged. All right, that was the bell, but we're going to still keep going, everybody. All right, number 3. Let's see, these ones, oops, sorry to tilt it on you. These ones are all about charge labeling. So it says, state the net overall charge of each metal sphere below. So let's see, if we want to classify these as either positive, negative, or neutral. So if I look on my metal sphere, I have 2 positive charges and 1, 2, 3, 4 negative charges. So I have an abundance of negative charges. So those overall would be negatively charged. If I look on the sphere to the right, I have 2 positive and 1 negative. So I have an abundance of positive charges. So that would make this sphere positively charged. All right, number 4, a positively charged metal sphere is as shown. Here it is. It's got 1, 2, 3, 4 positive charges and 2 negatives. Describe how you can make this sphere neutral. So it sounds like I need to ground it, just like the John Travoltage example, right? So I'm going to need to ground this. So ground to remove, let's see, hold on. Yeah, we can also ground it. We're not going to remove charges. Like in the John Travoltage example, we remove some charges. But here, we can ground to add negative charges to that sphere to then make it neutral. Ground to add negative charges to make neutral, right? So that's our goal. So you can just touch it with your hand, and some negative charges in the ground would come up. So if we touch this with our hand, boop, we would then have some negative charges come up from the ground. We would need, 2 more to do that job, right? So there's 2. And so we would have a result of our 1, 2, 3, 4 positive charges and 1, 2, 3, 4 negative charges, and we would then be neutral. Okay? Yeah, this is the symbol for ground, by the way, whether we're bringing charges up from the ground in this example or whether we're removing some with the John Travoltage example too. All right, on to number 5. Which sphere below is correctly polarized? So we want to see our charges separate. So here we have a negatively charged object, and here we have our sphere. It's neutral, 2 positive, 2 negatives. Same thing, right? 2 positive, 2 negatives, but which one shows it correctly polarized? Well, negative charges are like charges, and they repel. So this would not be the correct one here. So it looks like it's going to be this, right? Because our negative charges here are going to repel and go away from the negative source of charge. So this would be correctly polarized, right? But neutral. All right, number 6. This is kind of like a challenge question here, everybody, to take some thought. It says we have 5 metal-coated styrofoam balls here. So these are all conductors since they're metal-coated. Several experiments are performed, and we make some observations. That A attracts B but repels C, D attracts B and has no effect on E, and a negatively charged rod attracts both A and E. So I think one thing we want to keep in mind here, some little notes we'll take, are that like charges repel, and opposite charges attract, right? So that's, I think, one thing we want to keep in mind. Now, the other thing here, too, is that neutral things can also be attractive to charged objects when they become polarized. So that's the little tricky part here, is a neutral object can be attracted to a charged object by polarization. So I'm going to take the time to write these out. All right, via. Can I write via? Via polarization, because that's what's going to be the ultimate thing here to help us get this correct. So it says A attracts B and repels C. So that means that A and C are going to be the same charge since they repel each other, but A and B will be oppositely charged. So first example, and then it says a negatively charged rod attracts A. Okay, so if negatively charged rod attracts A, and A attracts B, and A repels C, all right, let's say that A is then a positively charged object. I'm going to go red here, everybody. So let's say this is positive, okay? It's going to attract B, so that would make B negative, and repels C, so it would make C also positive, okay? So that's where we're going to start. So I got that information from a negatively charged rod attracts A, so positive would be attracted to that negative rod. I'll draw a little negative rod in here, right? Negative. So that would be attracted to the negative rod, so it's going to have to be positive. Well, it could be positive, right? If it repels C, C is going to be positive. If it attracts B, that'll be negative. All right, so far so good. Now it says ball D attracts B, but has no effect on E. Here's our key thing. D has no effect on E. That must mean D and E are both neutral. Okay? So that is a little key point there. If there's no effect, if they don't do anything, then these are both going to be neutral if they don't attract each other, right? Because if they do attract each other, then one or the other is going to be charged. So if it says ball D has no effect on E, that automatically tells us these will be neutral. But you might say, well, hold on. How does D attract to B? Well, that would be through polarization, right? A negative charge can attract the neutral charge. The positive charges in here will be attracted to that negative charge. So that still works. A negatively charged rod attracts A and E. Sure, if I bring this negatively charged rod near E, the positives are going to be attracted to it, the negatives will repel, and it will therefore become polarized. So there's some tricky things there. These three ideas, especially this one, was key in our thinking there, that these neutral objects, they can attract to other things that are charged via polarization. All right, our last question here, number 7, and that is a positively charged rod is brought in contact with a neutral sphere shown. So here's our neutral sphere, our positive rod, and we bring it in contact, right? We touch it to it. So it says label the charges on the metal sphere after becoming charged. Now I'm going to be super specific with this one here, right? I'm going to count up the positive charges I have on the rod. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there's 10 positive charges there. Okay, so we'll say it's a plus 10. Now when it touches to this sphere, metal sphere, they're both conductors, so it's going to transfer some positive charges to this one, right? But you're like, well, how many? How many do I put on there? Because we know it'll keep the ones it has, so it'll keep these charges, and it's going to add positive charges. So what turns out, when I charge things by contact, they will split the overall charge. So if I have plus 10 overall, it means both of these items then will be plus 5 after charging by contact. So let me draw the charge rod here too, just so we've got it here, okay? So if I label these on there, that means it's going to give 5 of those charges to the sphere. So let's add 5 charges, 5 positives, 1, 2, 3, 4, 5. And that means this will have 1, 2, 3, 4, 5 on it, okay? That works, that keeps us in line with the conservation of charge, right? That I have 10 extra overall, but now those 10 extra are split. That I have 5 on the rod and 5 on the sphere. I'll label that, right? We have plus 5 and a plus 5. All right, great.